Okay, guys, this is going to be the first time I've recorded a video from home and using the new technology. The one downfall of this is there's really no way that I can figure out at this point to pause it. And so, because I'm at home, if you hear my dog bark in the background, just go ahead and say hi. It's Henry. Other things to note: this is our homework. We did bring back the book for this one assignment. It's just a few problems, but we're really going to be looking at measures of center and really focusing on how stats is a combination of pictures and numbers. So we're going to be really using those to work together. So if you don't already have the packet that looks like this, where it says stats, notes of measures of center, go ahead and pass those out now. Okay, today we're going to be talking a lot of mean, median, and mode. The reason why we're going to be talking about those is those are what we're going to be considering our measures of center. In the past, you might have heard them called the measures of central tendencies. Central, center, it's all going to be going back to the same thing, but we are calling those the measures of center. What we're going to use today is our prior knowledge on how to find these, and we're going to use those then to help see the relationship of what the picture looks like, and sometimes with the picture how it affects those as well. So it's going to be a back and forth ordeal. So the mean, another word for mean is we're just going to find our average just to kind of define what the mean is. And so when you're finding the average or you're finding the mean, you're adding them all up, and just to remind you, you're dividing by the total number. To define what median is, that's going to be cut the data in half or split the data in half. So it is also known as sometimes the middle of the data. And remember, if you have a bunch of numbers that you're crossing off, like the first one, last one, first one, last one, first one, last one, first one, last one, and when you get to the middle, that midpoint, if you have one number, you circle it. That one number that's left is your median. But if you have two numbers, let's just say they were 8 and 10, then you're going to add those up and divide by 2, which would give you 9, and then 9 would be the median. Okay, and then the mode is going to be the one that happens the most often, and that is the definition that we've used for years now. But what I'm going to challenge you is to start transitioning your thought of mode. Instead of being the one that happens the most often, we've been using the word peak a lot. If you think about dot plots, when you have a bunch of dots above one thing, that creates that peak. And so your mode is definitely going to be typically your peak of the data as well. Okay. All right, let's look at this. Finding some examples of mean, median, and mode. Well, the mean, if you take all these numbers and add them up, you go 14, 14, 15, 15, 15, and so on. Then we're going to have to divide it by, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. When you do that, you should find that the mean is approximately 16.13. I say approximately because I did round there. Please make sure you're calculating these as you go. If I'm going too fast, pause it and let everybody kind of calculate them as they go. Yeah, and so the median, then to find the median, what we're going to do is we're going to cross off the smallest, biggest, smallest, biggest, and keep moving back and forth until we get towards the center. So now I've done the same number of crossings on the left as I have on the right, and that leaves me with 1 right here. So our median then will be 16. Okay, and now we need to find the mode. The mode is going to be the one that happens the most often. Now what we could do is we could look at, I'm going to erase this, but we could look at our numbers and just kind of count. But if you look below, we do need to make a dot plot as well. So we might as well make the dot plot because it's really easy to see the mode once the dot plot's there. So I'm going to go down to the bottom and make that. I'm going to just start with 12. Notice I didn't mention, but whenever you find the median, the first step is always to line it up from least to greatest. The reason why I didn't mention it is because this data was already lined up least to greatest. So knowing that 14 is our biggest number, I think we should be able to go up by ones like this and have plenty of space. Okay, so we had two 14s, so I'm going to cross those off and put 2 dots. Remember, we're keeping them lined up and evenly spaced. We have 1, 2, 3, 4 15s. We have 1, 2, 3 16s. Again, if I'm going too fast, pause it. 1, 2, 3 17s. 2 18s and a 19. Okay. So now we can look at this and clearly 15 is our mode. Okay. So we're really not doing too much new material here. We are finding the mean, median, and mode, which is all should be reviewed from previous years. We're making a dot plot, which we did quite a bit last week. I'm going to work through B with you. See if I can get this moved. And we'll go through B, and then after I finish B, I am going to skip. Let's see, how many more are there? There's C, D, and E, and you guys can finish those on your own. We'll move on to just the notes. Okay, so I'll let you go ahead and get these written down. We're going to start off with our mean. Go ahead and calculate that. In order to calculate the mean, we're going to have to take 14 plus 15 plus 16 plus 16 plus 17, 17 and 17, and then 18, 18, 19, 20, and 21. We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. And I got a total or approximation of 17.3 repeating for my mean. I did just calculate that really quickly. You gotta love technology. Okay, so moving on, our median. I'm going to go ahead and graph this first and show you how you can use your dot plot to find the median as well. Okay, so we have a 14, 15, 2 16s, 3 17s, 2 18s, 19, 20, and a 21. So right off the bat, before we find the median, we might, or the yeah, the median, we might as well find the mode because we can see that that's going to be 17. So now you can use your pen to still cross these off. Because notice I'm still doing the smallest, then the greatest, smallest, greatest, smallest, greatest. Now here I've got 2 left. So when you have the 2 left, you add them up and divide by 2. But you should be able to see that 17 plus 17 divided by 2 is just 17. And so our median will equal 17. Now, just to kind of start to prep you for what we're going to be doing next week, we found that our, let's see here, 1, 2, 3, 4, 5. So our median then falls right in here. We found that next week then we're going to be finding this middle number and this middle number. And what we're going to call those are quartiles, or Q1 and Q3. This would be Q3 because this would, your median would actually act as your second quartile. And what quartiles really are your quarter marks. This is 1/4 of the data. This is the second quarter, the third quarter, and the fourth quarter to make up the whole. And so if you can't remember, the last time you guys talked about quartiles was when we were doing box and whisker plots. And so that's really what we're going to start looking into next week. So go ahead and finish these up. You don't have to do those now. We're going to keep moving on with the notes. But if there's time at the end of class, the first thing I want you to do is finish these, C, D, E, and F. And then you can get started on your homework. So moving on. Okay, now this is where we're getting into the exciting stuff. Oh, and by the way, I do realize that if you look all the way down, I didn't put it on here, but down at the bottom after E, there is a chart. That is a statistical chart, is a very common way that stats is given. I left it on there. It's a way that you can check your answers for the mean, median, mode. I want you to actually calculate them. I had the option to be able to take it off, but I decided that it would be important for you to see how statistics are normally given in the everyday world. And that's typically how they look. And so after you finish each letter, look at that, check your work, because realistically, when you guys will need to use mean, median, and mode, you're going to have computers that'll compute that all for you anyway. And so it's important to know how, but it's also important to realize how to read reports that the computers might produce for you. And so that's an example of one down at the bottom. Okay, moving on. When the shape of a distribution is symmetric, the mean and median are what? Well, this is the exciting material because they're going to be the same. And what's exciting about this is we're now starting to see how the data can affect the graph. So how our numbers can affect the graph. But we're also going to see how then the graph can kind of tell us something about the numbers. And so we're going to be able to work both ways with this. But this whole idea of symmetry and symmetric, we use that very loosely up until this point. We said things like sort of and roughly and kind of symmetric. Now we're going to start diving into the exact meaning of symmetric. Technically, a graph or a set of data is exactly symmetric when the mean and the median are the same or when they're equal. Okay, so anytime a graph, whether it looks like this, is perfectly symmetrical, you're going to see that middle point right here be the median, but it will also be the mean or your average. So sometimes this kind of bell curve is an excellent example of symmetry. You might also see something that looks like this, where the median then lies right here. and that would also be the mean as well. And so we're going to be able to look at a graph that's perfectly symmetric like this and say, hey, even without computing anything, because it's perfectly symmetric, we know that the mean and the median are going to be the exact same. But we're also going to be able to look at data like what we did over here, and anytime we see the mean and median be the exact same, then we know that the shape is going to look very symmetric like this as well. So we know just by looking at the numbers what the graph might look like, or looking at the graph what the numbers might be like. I'm looking back to this. If you look at this first example, this is why we would call this one roughly symmetric. As you can see, the mean and the median are very close. They are almost exactly there. Same thing here. This one has a lot of symmetry as well. It is really, really close to being symmetric. In fact, if you look, you've got this extra point right here is the only thing that takes it from being exactly symmetric. Okay, so now let's look at a real life scenario. What happens when there are these outliers? Okay, or when the distribution is not symmetric. This is a good example. It's the player salaries for the 2013 New York Yankees, so last year's New York Yankees. They took all the main players that played on the team and made a dot plot of their salaries. And so, as you can see, there's not very much symmetry. If you look down further, I don't know if I put that over here, but yes, here's your mean. Okay, the mean, then it actually asks what is the mean right here. The mean would be, let's see, where's our comma? About 8,200,000 if we were to round it. Okay, and then the median would be approximately 935,000. Because as you can see, the median right here is 935,000. So when we're comparing the mean and median, as you can see, those two numbers are way far apart. Because they're so far apart, we know that there is not going to be much symmetry, if any symmetry at all, in this graph. So when we look back to the graph, it's no surprise there's absolutely no symmetry here. We can find the median on our own, like so. And here comes my dog, so you guys might get lucky and get to hear him. Okay, we're working through them. And so our median is this one right here. And notice it's not on the 0, it's just past it, but because they're going up by such big intervals here, that actually, the median falls right there, and that's where the 935,000 was. And our mean then was, let's see, 8,200,000, so that would fall right about there. Okay. And so why do you think there was such a big separation? Well, when we analyze this, what kind of players do you think are going to be right there? Those are all going to be your stars. I'd like to say great players, but we all know that sometimes when you pay one person a lot of money, they don't live up to the hype sometimes. But for the most part, your best players are going to be right here. But it's definitely the ones that are the most well-known and that bring in a lot of money. But majority of your team is actually on this end. Okay. So we've actually answered a few of these questions already. So we found the dot that represents the median. We already did that. Why do you think the salaries, we just talked about why they're so skewed like that? Because there's a good chunk of players that just make quite a bit of money. We've talked about these, and if we look at question number 4, would you rather make the median salary or the mean salary? Well, looking back, or just looking at the numbers, I think we'd all probably shoot for this mean salary. And the main reason why is that it is much larger. Maybe there are a few of you that would actually like to make less money. I find it hard to believe, but I guess it's possible. Okay. Okay. For these, oh, I did want to point this out, which is at the bottom of the page. Anytime the data is not symmetric or when there are outliers, the mean will always be pulled in the direction of the outliers. And that's what gives us this long tail. So let's go back to our graph, kind of analyze what that means. So if you notice, these would probably be considered your outliers. Definitely this, but here's your kind of cluster of outliers here. They're definitely clearly separated from majority of the players or majority of the team. And whenever you're mean or whenever you have outliers, the mean is always going to be pulled closer to that. And so in a perfect world, the median and mean are going to be the same thing. Anything that's perfectly symmetrical, okay, that's not very symmetrical. Let's try that again. Okay, perfectly symmetrical, the mean and median both will fall here. But what throws things out of symmetry are outliers. So if there's an outlier over here, then let's see if this will work. This is going to get stretched to come over to that outlier. And so as you can see, the median stayed the same, but the data kind of stretched over here. And so that's what would happen for the the mean always follows the outliers. If the outlier were on this side, then the mean is going to be closer over here. Okay, which is what gives it that unsymmetric look. Okay. All right, the rest of it, I believe, is fairly self-explanatory, and you can go ahead and finish these final parts in groups. Then after you're finished with this group work, then go ahead and finish parts, C, D, E, and F. I guess there's not an F. C, D, and E over here, and then you can get started on your homework. Here's your homework. Make sure you have it written down, and I will see you guys on Monday.